Technology Risk Part 5. This episode has 22 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Cloud risk. What are common cloud misconfiguration risks? Here's a strong way to approach it. Common misconfigurations include publicly accessible storage buckets or databases, overly permissive firewall rules, 0, 0, 0, 0 or 0 on sensitive ports, IAM roles granted more broadly than needed, missing encryption on data at rest or in transit, disabled or unmonitored audit logging, and default credentials or settings left unchanged after resource creation. Most of these are preventable with policy as code guardrails enforced automatically rather than relying on manual review to catch every instance. Nice. Let's continue. Question 2. Kubernetes or DevOps risk. What are the risks of CI or CD pipelines? Here's a strong way to approach it. Risks include overly broad credentials granted to the pipeline. A compromised pipeline can deploy or exfiltrate data anywhere those credentials reach. Unreviewed third-party actions or plugins that could be malicious or compromised. Secrets leaking through build logs or artifacts. Insufficient separation between environments allowing a change to unintentionally affect production. And a lack of approval gates letting a single compromised or careless commit reach production without review. Great. Moving on. Question 3. Kubernetes or DevOps risk. How do you secure Jenkins? Here's a strong way to approach it. I secure Jenkins by enabling SSO or MFA, RBAC, credential store controls, plugin hygiene, isolated agents, network restrictions, audit logs, backup, CSRF protection, limited admin access, pipeline code review, secret masking, and regular patching. Jenkins should not have broad production credentials unless tightly controlled. Alright, next question. Question 4. Kubernetes or DevOps risk. What are the risks of GitHub Actions? Here's a strong way to approach it. Key risks include using mutable action tags, @v1, that can be silently changed upstream to inject malicious code, mitigated by pinning to a commit SHA, overly broad GitHub token or secret permissions granted to workflows, third-party actions from unverified publishers with supply chain risk, and workflows triggered by pull requests from forks potentially executing untrusted code with access to repository secrets if not carefully scoped with the right trigger and permission settings. Let's keep going. Question 5. Kubernetes or DevOps risk. What is supply chain security? Here's a strong way to approach it. Supply chain security protects the integrity of code, dependencies, build systems, artifacts, and deployment paths. It covers dependency scanning, SBOMs, provenance, signed commits or images, trusted builders, artifact promotion, and policies that prevent unverified artifacts from reaching production. On to the next one. Question 6. Kubernetes or DevOps risk. What is an SBOM? Here's a strong way to approach it. An SBOM, or Software Bill of Materials, is an inventory of software components, dependencies, versions, and sometimes licenses. It helps teams understand exposure when a vulnerability is discovered and supports compliance, vulnerability management, and supply chain transparency. Good. Here's another one. Question 7. Kubernetes or DevOps risk. Explain image signing. Here's a strong way to approach it. What is image signing? Image signing is the process of digitally signing a container image, Docker image, to verify. Nice. Let's continue. Question 8. Kubernetes or DevOps risk. What is runtime security? Here's a strong way to approach it. Runtime security monitors and controls workloads while they are running. It includes detecting suspicious processes, privilege escalation, unexpected network connections, file changes, and container escapes. In Kubernetes, runtime security complements image scanning because some attacks only appear after deployment. Great. Moving on. Question 9. Kubernetes or DevOps risk. What are the risks of Helm charts? Here's a strong way to approach it. Risks include pulling charts from untrusted or unverified public repositories that could contain malicious templates, Overly permissive default values, like disabled security contexts, that get deployed without review if teams don't inspect rendered manifests. Secrets accidentally baked into values files committed to version control, and chart dependency chains that are hard to audit fully, potentially pulling in unreviewed subcharts with their own risky defaults. Alright, next question. Question 10. Kubernetes or DevOps risk? What are Kubernetes RBAC risks? Here's a strong way to approach it. Risks include overly broad cluster role bindings granting cluster-wide access when namespace-scoped access would suffice, use of the wildcard in rules granting unintended permissions as the API evolves, service accounts with more permissions than their workload actually needs, violating least privilege, and stale bindings left over from decommissioned services or departed team members that nobody remembers to clean up, silently expanding the attack surface over time. Let's keep going. Question 11. Kubernetes or DevOps risk? What are the risks of privileged containers? Here's a strong way to approach it. A privileged container has essentially unrestricted access to the host. It can access host devices, modify kernel parameters, and in many cases break out to gain control of the underlying node, meaning a single compromised privileged container can compromise the entire node and potentially the cluster. This is why security baselines, pod security standards, admission controllers, block privileged containers by default, only allowing exceptions for genuinely justified cases like specific infrastructure-level agents with clear compensating controls. On to the next one. Question 12. Incident management. Describe your incident management process. Here's a strong way to approach it. I start with detection and triage. Declare severity. Assign roles such as incident commander and communications lead. Stabilize service. Communicate impact. Mitigate or roll back. Preserve evidence. And track timeline. After resolution, I run a blameless postmortem and convert root causes into prioritized action items. Good. Here's another one. Question 13. Incident management. What is the difference between incident, problem, and risk? Here's a strong way to approach it. An incident is an unplanned event actively disrupting service that needs immediate response. A problem is the underlying root cause behind one or more incidents, addressed through investigation and permanent fix rather than urgent firefighting. A risk is a potential future event that hasn't happened yet but could cause harm, addressed through proactive mitigation before it ever becomes an incident. The distinction matters because each requires a different process. Incidents need speed, problems need root cause rigor, and risks need foresight. Nice. Let's continue. Question 14. Incident management. How do you perform root cause analysis? Here's a strong way to approach it. I build a timeline, collect logs and evidence, identify immediate cause, contributing factors, control failures, and systemic gaps. I avoid blaming individuals and focus on why the system allowed the issue. The output should include corrective actions, owners, due dates, and validation that fixes work. Great. Moving on. Question 15. Incident management. What is a postmortem? Here's a strong way to approach it. A postmortem is a structured review after an incident. It documents what happened, impact, timeline, root causes, what went well, what did not, and action items. A good postmortem is blameless, evidence-based, and focused on preventing recurrence. Alright, next question. Question 16. Incident management. Explain the 5 whys technique. Here's a strong way to approach it. The 5 whys technique repeatedly asks why an issue happened until the team reaches deeper contributing causes. For example, a service went down because a config changed. Why was it wrong? Why did tests miss it? Why was there no approval? Why did the control not exist? It helps move beyond symptoms. Let's keep going. Question 17. Incident management. What is a near miss? Here's a strong way to approach it. A near miss is an event that could have caused an incident but did not, often because of luck or a late control. Near misses are valuable because they reveal weaknesses before harm occurs. They should be reviewed and tracked like risks. On to the next one. Question 18. Incident management. How do you prevent recurring incidents? Here's a strong way to approach it. I prevent recurrence by identifying root causes, fixing systemic gaps, adding controls, improving monitoring, automating checks, updating runbooks, testing recovery, and tracking post-mortem actions to completion. I also look for similar weaknesses in other services. Good. Here's another one. Question 19. Incident management. What KPIs do you track? Here's a strong way to approach it. Incident KPIs include MTTD, MTTA, MTTR, incident count by severity, recurrence rate, post-mortem action closure, change failure rate, deployment frequency, rollback rate, vulnerability slaw compliance, control failure rate, and alert noise. For risk reporting, I also track crees and trend lines. Nice. Let's continue. Question 20. Incident management. What is mean time to detect? MTTD. Here's a strong way to approach it. MTTD measures the average time between the start of an incident and when it is detected. Lower MTTD means monitoring and alerting are effective. To improve it, I use user impact alerts, logs, metrics, traces, anomaly detection, and clear ownership. Great. Moving on. Question 21. Incident management. What is mean time to recover? MTTR. Here's a strong way to approach it. MTTR measures the average time to restore service after an incident is detected or starts. Depending on the definition, it improves with good runbooks, automation, rollback, tested backups, incident roles, reliable observability, and practiced response. Alright, next question. Question 22. Monitoring or reporting. What risk metrics do you monitor? Here's a strong way to approach it. I monitor open risks by severity, overdue remediation, control failures, access review completion, privileged access changes, vulnerabilities by slaw, patch compliance, public exposure, backup success, logging coverage, incident recurrence, audit findings, and risk acceptances. Metrics should show both current posture and trend. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.